Hello friends, welcome to Susan and John MathTube. In this video, we are going to continue our discussion based on areas in polar coordinate system. In the last two videos, we saw how to calculate area in the polar coordinate system. And in the last video, we did like two very important questions. One was cardioid and another was cardioid and a circle, the area between cardioid and a circle. And these are questions from your past year question papers. And in this video, you're going to see a lot of new polar curves, but it has a pattern. And right in front of you, we have r is equal to a. And I have already introduced you to this curve, r is equal to a. It's a circle. Because you input any number. So look at this. This is our pole. I think you can see the pole. I made it look a little bit big. And actually, this is r is equal to 2. That is why you are able to see 2 units here. So you input any angle, r will remain 2. So we get a circle with center pole and radius 2 units. And the next one, r is equal to a sine theta. And again, we have the pole over here and our initial line. And I told you, I made it a little bit thick so that you can understand. And this is our 90-degree line. So maybe this is 45 degrees. So 60 degree. It goes on like this from 0 to, So when you move from 0 to 90 degree, half the circle will be covered. So this is a sine theta. Now comes another one, a sine 2 theta. You should be very good with this curve. And exam point of view also, this is very important. R equal to a sine 2 theta. If you want to know how the loops are formed, it's very easy. All you have to do is you have to put r equal to 0. And that gives you a sine 2 theta equal to 0, which eventually becomes sine 2 theta equal to 0. And that means 2 theta will be equal to n pi, because sine theta becomes 0 when you have multiples of pi. So theta will be n pi by 2. So you can put n equal to 0, so you get 0. That is the pole. This one. I made the pole too thick. Anyway, you can understand. This is the pole. And again, you can put n equal to 1. So we have 90 degree. It's here, right over here, 90 degree. Okay. And this will be theta equal to pi by 4, 45 degree, the middle. And remember, it's a symmetric thing. So if you can find this much, if you integrate from 0 to pi by 4 to find the area, you can find the area of one loop by doubling it. And again comes sine 3 theta, etc., etc. So we'll meet the curves one by one. So my job is very simple today. I have to initiate or give some ideas so that you can calculate the area of all these equations. So point number 1, we are in polar coordinate system. And you can identify polar coordinate system by just looking at the equation. There will be no x and y. Instead of x and y, r and theta will be used. And in the polar coordinate system, area is given by 1 by 2 integral r square d theta. This is the area between theta 1 and theta 2. Okay, so let's start. I think we already did circle, but I'll still give some hint. So how do you find the area of a circle? So you can note the first question. Find the area of the circle. R is equal to A. We have the circle over here. So look at this, my friends. This is theta is equal to 0 degree. And maybe this is 30 degree, then 45 degree, then 60 degree, and it goes on like this till we reach 90 degrees. And if you reach 90 degrees, you're actually covering 1/4 of the circle. So required area will be 4 times integral theta varies from 0 to pi by 2 1 by 2 r square d theta. And what is the value of r? R is a. So what is the value of r square? A square. So you take everything outside, 1 by 2 a square, and integrate. You will get the area as pi a square. We already done in the last video, so I am not going to elaborate. Okay, now this is something new. Suppose they ask, evaluate the area of the circle r equal to a sine theta. First of all, you have to understand, if you move from theta is equal to, okay, I'll use another color. This is theta is equal to 0 degree. My initial line became too thick, but I did that so that you can understand that that's the initial line. And this is, let's say, 30 degree, maybe 45 degree, etc, etc, etc. When you reach 90 degrees, is theta equal to pi by 2. You can see that half the area of the circle will be covered. So if they ask you the question r is equal to a sine theta, so you have to write required area. So can you tell me what will be the required area? Is 2 times integral theta equal to 0 to pi by 2, because you saw that it started from 0 and I moved slowly towards pi by 2, so that I am able to cover half the area. So that is why I took 2 times 1 by 2 r square d theta. So 2 and 2 will get cancelled, and that gives me r. What is the r value? A sine theta. So that will be a square sine square theta d theta. And please remember, in this equation, a will be the diameter, and that means a by 2 will be the radius. Anyway, we have a shortcut to evaluate this. I hope you remember the shortcut. It is called reduction formula. If not, watch my previous videos. So it will be like 2, 1 and pi by 2. So the answer is pi by 4 a square, which is correct because the radius is a by 2. So pi into a by 2 the whole square is the area. Okay, similarly, okay, now this is very important because they have asked this question in the exam. So they will ask you, evaluate, and be very careful. Sometimes they will ask, evaluate the area of one loop. Sometimes they will ask, evaluate the area of all the loops. So make sure you read the question properly. Don't jump into a conclusion by just looking at the question. So look at this. If the question is area of one loop, then you have to find the area of only one loop. If the question is find the area of all the loops, then you have to multiply by some number so that you will get the total area. Anyway, the most important thing to notice is this is theta equal to pi by 4. And I'll strongly recommend, draw this picture and keep it neatly somewhere so that when you prepare for the exam, it will be very easy for you to recollect. Okay, now look at this. All I'm going to do is I'm going to find the area from 0 to pi by 4. Or if I want, I can find the area from 0 to pi by 2 and multiply by 4 times. But do you know why I am doing that from pi by 4? If you are very smart in beta gamma functions, which you learned previously, I'll repeat, if you are good in beta gamma integrals, you will understand why we are doing from 0 to pi by 4 instead of 0 to pi by 2. So look at this. I'm going to calculate total area. Total area means area of all the 4 loops. So that will be 8 times integral 1 by 2 r square d theta. And I'm going to integrate from 0 to pi by 4. If you don't want to do this, you can do like this. 4 times integral theta is equal to 0 to pi by 2 of r square d theta. But I don't prefer this, I prefer this. Can you guess? Okay, your guess is correct. The angle is 2 theta. So to adjust that, we have kept pi by 4 here. Let's go for that. So we get 4 into theta equal to 0 to pi by 4. R square will be a square sine square 2 theta d theta. And that will be 4a square. If you want, you can put 2 theta is equal to t. So theta will be t by 2. So d theta will be dt by 2. And if theta equal to 0, t will be 2 into 0. And if theta is equal to pi by 4, t will be 2 into pi by 4, that is pi by 2. And that is my aim. So t becomes 0 to pi by 2. I did all those things just for this. That's why I took half the area. So we get sine square t. And d theta is dt by 2. So I'll write dt here and I'll write that by 2 over here. I hope you're able to work out. And I already explained the shortcut 2, 1 and pi by 2. If you didn't understand, that means you have not watched my previous videos. So please check the first video in areas. So the answer is pi a square by 2. I hope you like the trick. Okay, now let's move on. Okay, this is another question which they asked in the exam. Find the area of one. Again, I'm telling you, you have to be very careful. Whether they ask find the area of one loop or all the loops. And I checked one past paper question from 2072 Karthik. And I found the question find the area of one loop. Okay, so let's do that. Find the area of one loop. So please be very, very, very careful. So I'm going to find from this much. And this is actually pi by, if you're confused, I have one method. Equate this r to 0. So we get sine 3 theta is equal to 0. So 3 theta is equal to n pi because sine becomes 0 like that. So theta equal to n pi by 3. That means when we put n equal to 0, we get 0. When n equal to 1 is pi by 3. And then 2 pi by 3. Then 3 pi by 3. Then 4 pi by 3. And then 5 pi by 3. And then 6 pi by 3, which is 2 pi. So that is why it meets again and again and again and again and again and again and the same point. Look, they actually meet 1, 2, 3, 4, 5, 6 times and the same point. Anyway, I want only this much. So if I draw a tangent here, this is actually pi by 3. And this is 0 degree. So this will be, let's go, that midpoint, that is pi by 6. So the required area will be integral 2 times. Look at this, I'm going to find only for one loop. And I think you understood why I am dividing that loop into 2. So that integration will be very, very easy. 2 times theta is equal to 0 to pi by 6. 1 by 2 r square. What is r square? A square sine square 3 theta d theta. And my preferred method is substitution method. If you want, you can use other methods. Anyway, I'm going for substitution method. So I put 3 theta is equal to t, theta equal to t by 3. So d theta equal to dt by 3, etc, etc, etc. You try it yourself. Okay, moving ahead. Again, I showed this r equal to a, which you're familiar with. It's a standard circle with radius a units. Now, instead of sine, what I did is I used cos theta. I think you got the pattern. What we did till now is like r is equal to r is equal to a sine theta, then r is equal to a sine 2 theta, then r is equal to a sine 3 theta. This was the pattern. Now the pattern will be r is equal to r is equal to a cos theta, r is equal to a cos 2 theta, r is equal to a cos 3 theta. So look at this, you can once more check the pictures. That's exactly what we did. Circle, circle, again 4 loops and 3 loops, and okay, so let's move on. So if they ask find the area of this circle, you should remember this is 0 degree. This is our initial line. So this is theta equal to 0 degree and this is theta equal to 90 degree or pi by 2. So when you move from 0 to pi by 2, you cover half the circle. And remember, the diameter of the circle is a units. So the required area is equal to 2 times area above the initial line. And that will be integral 1 by 2 r square d theta. And theta is from 0 to pi by 2. And as always, you plug in that value. That's it. You try it. You try it and tell me whether you found the answer or not. But make sure you try it, and in case you have any doubt, ask me. You can contact me through my website www.sjmathtube.com. So the next one, r is equal to a cos 2 theta. I will remind you once more. Check 100 times whether they asked the area of one loop or 2 loops or all the loops. Anyway, I'll teach you how to find the area of one loop so that you can find the area of all the loops in case they ask. Okay, so in cos theta, actually the figure has shifted 45 degrees backwards. The reason is very simple. If r equal to 0, then eventually we end up with cos 2 theta equal to 0. So 2 theta will be equal to 2n pi plus or minus pi by 2. That's a general solution. And that actually gives me theta equal to n pi plus or minus pi by 4. And if you plug in 0, I can see that it's between theta equal to minus pi by 4 and theta equal to pi by 4. Anyway, I'm going to find this much area, half the loop. I'm going to find the area of half the loop. So the formula for one loop is, listen once more, I'm going to find the area of one loop, that will be 2 times integral 1 by 2 r square d theta, and the limits are from theta equal to 0 to pi by 4. And that gives me theta is equal to 0 to pi by 4. R, what is R? Yeah, a square cos square 2 theta d theta. And there are many techniques to evaluate this, but my favorite is substitution. Because I know this 2 theta and pi by 4 are going to give me something good. So I put 2 theta is equal to t. So theta is equal to t by 2. So d theta will be dt by 2. So we need this. And the next thing is, if theta is equal to 0, t is equal to 2 into 0, that is 0. If theta is equal to the upper limit pi by 4, t will be 2 into pi by 4, that gives me pi by 2. And there comes my favorite integral, t is equal to 0 to pi by 2. This a square I am going to write outside, and cos square t dt by 2 will come, so that I keep it here, because I think you saw d theta is dt by 2. And that's it, my friends. Now you know the shortcut, 2, 1, pi by 2. So the answer is pi a square by 8. Okay, so let's do the last question and wind up this video. Okay, look at this. Use the same logic I told you if you don't remember the picture properly. But it is better in your exam like what you call, if you know the picture, it's better, much better. Anyway, we end up with cos 3 theta is equal to 0, that is cos 90. So we get the general solution 2n pi plus or minus pi by 2. So theta will be 2 by 3 n pi plus or minus pi by 6. Anyway, when I plug in n equal to 0, I get plus or minus pi by 6. So this is pi by 6 for sure, and here we have theta is equal to minus pi by 6. But I don't care, because I told you my logic in all this is finding half the loop. So look at this. For the last time, I'm going to give the warning. In your question paper, there are two types of question. Sometimes they will ask, find the area of the curve. Or they may ask, find the area of all the loops. That means multiply by a proper number so that you get the total area. But sometimes they will ask, find the area of one loop. And that is exactly what I'm going to do. I'm going to find the area of half the loop. So come on, tell me, what will be the limit? Area is equal to 1 by 2 integral theta is equal to 0 to pi by 6 r square d theta. And I have to multiply by 2 because it's symmetric. And that gives me the area of one loop. And as always, the question, what is r square? R is here. So that will be a square cos square 3 theta. So my favorite method, I'm going to substitute. So I'm going to put 3 theta is equal to t, theta is equal to t by 3, d theta is equal to dt by 3. And then the limits. If theta is equal to 0, t will be 3 into 0, that's 0. And if theta is equal to pi by 6, t will be 3 into pi by 6. And what am I going to get? Yeah, pi by 2. So we end up with a square t is equal to 0 to pi by 2 cos square t dt by 3. I'll put the 3 here. And then my favorite trick, reduction formula, 2, 1, pi by 2. So the answer is pi a square by 2, 12. Okay, now if you want the total area, you just multiply by 3 and that will be pi a square by 4. So that's it. So once more, I'll give you a review. Yeah, I'll stop here. So today we learned how to find the area of a lot of curves. R equal to a, r equal to a sine theta, r equal to a sine 2 theta, sine 3 theta, cos 2 theta, cos 3 theta. So make sure you practice again and again till you're perfect. And one more thing, I'll strongly recommend draw these graphs somewhere so that in exam time you can refer very fast and do a quick revision. So I'll be back with more videos. If you like the video, please share and subscribe. So I'll be back soon. So till then, my friends, bye.